everyone. So in this video, I would like to talk about effective annual yield. So the first thing, effective annual yield is the simple interest rate that would produce the same amount of future value, the same amount of money in our account as something that would be subject to compound interest. So this gives us a way that makes it really easy to compare different investments. If everything is expressed in a simple interest rate, we can compare those rates, and whatever rate is the better investment. So I want to talk about how we find this. So let's take a look at an example and we'll talk through the process. So this one says you deposit $4,000 in an account that pays 8% interest compounded monthly. Okay, so compound interest. I want to find the future value after 1 year, and then let's use the future value formula for simple interest to find the effective annual yield. So for letter A, we need to use our compound interest formula. So remember, that is our principal times 1 plus r over n raised to the nt power, and n is the number of times we compound in a year. So if we plug in what we know, our initial investment, our principal is $4,000, 1 plus our rate, which is 0.08, and since we're compounding monthly, n is going to be 12. And then in our exponent, n is 12 again. And we're only doing this for 1 year, so we'll multiply that by 1. And so now we can type this into our calculator. And again, we just need to make sure that we work our way from the inside out. So we have 0.08 divided by 12. We'll do our decimal first. To that, we're going to add 1. And then this is what's inside our parentheses, and that's going to be raised to the 12th power. So we get about 1.083, and then we're going to multiply that by 4,000. Okay, so taking a look at our future value, $4,331.99, and then just rounding up here, we can round that to $4,332. So our future value, $4,332. So that's what we end up with in our account, compounded monthly after 1 year. But now I want to find the effective annual yield, which is the simple interest that would give me this same amount of money. So remember our simple interest formula, our future value is equal to the principal times 1 plus r times t. Okay, so we can plug in what we know again. So the future value we want to end up with is the $4,332 we just found. Our initial investment, the principal, is the same, 4,000. And then 1 plus r is actually what we want to solve for, and t is actually just going to be 1 because we're still looking at 1 year. So to solve for r, the first thing is I'm going to divide both sides by 4,000. So we get 4,332 over 4,000. That's going to be equal to 1 plus r. And then to isolate the r, we'll subtract 1 from both sides. So 4,332 divided by 4,000, and from that we're going to subtract 1. If I simplify that and I get my decimal, that's going to be our rate written as a decimal. So then to finish up, we can multiply by 100 to get our percent. So let's take a look and see what we get. So 4,332, we'll divide that by 4,000. That's 1.083. And then from that, if we subtract 1, our rate as a decimal is 0.083. So our rate as a decimal, 0.083. And multiplying this by 100, we get our answer, our effective annual yield. So I'm going to call it Y for yield. We end up with a rate of 8.3%. So what that means is that if I had a simple interest rate of 8.3% and I had the same investment of $4,000, I would end up with the same future value as this interest that's compounded monthly. So if I had multiple investments and they were different interest rates and maybe they're compounded a different number of times, I could take each investment, convert it to an effective annual yield. That would tell me, simple interest rates for each of these accounts. I could compare those. Whichever one has the best interest rate would be the better investment.